All right, so important to remember, a function is even if f of negative x is equal to the original output, or the original output. And if it is odd, this means it's even. If it's odd, that means that f of negative x is equal to the original output, but negative, right? So if we think of just a regular quadratic, this is an even function, okay? You can fold it across the y-axis, both is the same on each side, and both ends go the same direction. Now, if I put in a positive 2, my answer is positive 4, because this is x squared, okay? If I put in negative 2, my output is still positive 4. That's what makes it even. So even if I put in the negative value, I get out the same, I get the same output that I did if I put in the positive value. That's all that means. And for an odd function, it means if I put in the negative value, I get the original number, but it's an odd number. So if we turned this function, it's not into a cubic function, x cubed, that is like this, then if I had put in positive 2, my output would be 2 times 2 times 2, which would be 8. Okay, my output is going to be 8. But if I put in negative 2, my output's going to be negative 8. Okay, so that's the difference. So this is what I'm going to use to test this. So for A, everywhere I see an x, instead I'm going to put a negative x, and then see what I get out. So f of negative x here is going to be equal to negative x cubed minus 4 times negative x all over 2 times negative x to the 5th power. So let's start simplifying this. Negative x cubed is negative x times negative x, which is positive, but then times a negative x, which is negative, just gives me my output is negative x cubed. Okay? Negative 4 times negative x is actually going to be plus 4x. Okay? And then over negative x to the 5th power is going to be 2 times negative x to the 5th power, but I can bring that negative out and call that negative 2 times x to the 5th power. Okay, and then what do I get here? Nope, that won't work. I can factor out an x on the numerator. Actually, let me factor out a negative x on the numerator. And then this would leave me, if I factor out a negative x, I get x squared, positive, minus 4. And I did that on purpose because what I wanted to do is also factor out negative 2x. What do I have left over? X to the 4th. Okay, and I wanted that because this becomes positive and this x cancels with this x. So my reduced form, if I enter in a negative x, is going to be x squared minus 4 over 2x to the 4th, positive. Okay, so I'm going to leave that there and delete this and simplify, see if I can simplify the first one to get the same answer. Okay, so if I just simplified this without making x negative, I could factor out x from the numerator, same. Then I have x squared minus 4, okay, and 2x, I can factor out 2x times x to the 4, okay, Here my x's cancel, and everything's positive, so I get the same exact thing. So if I enter in a negative number, I get the same thing as if I entered in that positive number, right? This, if I had just simplified the original, this one, I get the same as if I simplified with a negative number. So it's even, and that's justified. Like all of that math justified it. And then you can just put it in the calculator and check it graphically. You could just do that graphically. I'm not sure on the actual test what it wants you to do. I do know that this test review is much harder. So please remember you do have your calculator for all of this. I'm going to erase this. I'm going to try the second one. It looks a little bit easier. Anything that's not a rational function seems a little bit easier, right? So first of all, we can just, let's reduce this one first. Let's do it. I think I did the other one backwards, right? If we reduce this, I get 3 times x minus 4 squared is really x minus 4 times x minus 4. So you can do your area model if you want. X minus 4 is get x squared minus 4x minus 4x minus 8x plus 16. Okay, so we have x squared minus 8x minus 16, plus 16, because there are 2 negatives, plus 7. Okay, so if I distribute that 3, I now have 3x squared minus 8x plus, let's see, 18, carry 1, 3, 48, plus 7 still. So all that does is it changes that 48 to be, instead of plus 48, plus 55. Okay. Now let's make that x negative, and we can reduce it all again, just for kicks. But instead it will be 3 times negative x minus 4 squared plus 7. So that changes my area model to be negative x minus 4, negative x minus 4. I still get plus 16. I still get, but here it's a positive 4x, and here it's a positive 4x, and x squared. So I have 3 times positive x squared, but instead of minus 8, it's plus 8x, but it's still plus 16. And then on the outside, it's plus 7. Now I distribute the 3. I get 3x squared plus 24. Ooh, did you guys see that? I made that mistake down there. This should have been minus 24x. Doesn't change anything else. Plus 24x plus, what was that? 48 plus 7. 48 plus 7 we know is really 55. Okay. Plus 55. And you can tell that although it looks close, and although I know what you're thinking to yourself, but this is negative 24x and this is positive 24x, so isn't that correct? No, because you have to take into account these other pieces, right? They are the same, so it's not like one is positive and one is negative. And while I was doing this, I had a thought. I actually paused and checked. This is an easier way to check yourself graphically. What I did was, look, I put in for the first one, because I was checking my answer graphically. I was like, was I correct? Was I not? Before I said anything. And what I did was I put in both. So look at y1. I put in the original 3 times x minus 4 squared plus 7. And then I put in the new 3 times negative x minus 4 squared plus 7. And then I graphed both of them. And here's the thing. If they were the same graph, they would be even. Okay, so let's see. There's the first one, there's the second one. No, they are not even, because you don't get the same output when you put in the opposite input. But I could also tell if we just look at the original one I graphed, the original one that we were working on. I can tell that it's not, whatever I enter in here, if I enter in the negative of that, it is not going to give me that other negative number. It is not symmetrical about the origin. Okay, so you can tell that. Now, the cool thing was I went back and checked my answer on the first one to make sure it was even. So in y3, I have x cubed minus 4x divided by 2x to the fifth power. And in y to the fourth, I have negative x cubed, and I put that in parentheses, minus 4 times negative x divided by 2 times negative x to the fifth power, and I graphed. And as you can see, there's the first one. Okay, and there is the second one, and they're exactly the same, because even if I put in a negative input, I get the same output, so you can tell that they are even. Okay, so that might help you a little bit more when you're working on even and odd functions. What's next? Okay, sketching functions. We're almost at the end of this one, but I will tell you, sketch a graph of the function 2 to the square root of x minus 3 plus 1, okay? All that is we are taking, well, first of all, sketch a graph of it, put it in your calculator. I don't think you have to do that by hand on the test. And then it says sketch a graph of the inverse of that. So all that means, all the inverse is that for every x and y value, you are going to switch your x and your y. So if you have a sketch, let's do that in the calculator. So if I put this into the calculator, y equals, there's 2 times the square root of x minus 3 plus 1. I graph it. This is what the graph looks like, okay? If I want to sketch a graph of the inverse, then I switch the x and the y. So all I have to do is go to the table, right? And all you have to do is switch. Oh, it doesn't exist. Okay, instead of the 0.31, you're going to do the 0.13. Instead of the 0.43, you're going to do the 0.34. You don't want to do any decimals. Let's see if we can find, there's one. Instead of the 0.75, you want to graph the 0.57. So when you're sketching a graph of the inverse, all you have to do is flip your input and your output. That's because what's the way that we write an inverse? We switch the x and the y, right? Instead of y equals, we have x equals, right? So we are literally flipping the x and the y, okay? If you want to write an equation for this, then we will do, oh, I've got 2 minutes. So we switch the x and the y, and 2x, or y minus 3 plus 1, subtract 1 from each side. It's going to be x minus 1 equals 2 root y minus 3, divide both sides by 2. That's going to cancel that out. Square each side, x minus 1 over 2 squared equals y minus 3. Add 3 to both sides, x minus 1 over 2 squared plus 3 equals y. This, whoops, squared, yep. This should be your inverse of this one. But we have to have the same restrictions on domain. So here, if this was going to be 0, x would be 3, which would work, but x cannot be smaller than 3. So the same thing here, our domain would be x must be greater than or equal to 3. We'd have to restrict the domain around that. I'm going to graph it and show you what it looks like. Okay, so I paused it and put it in the calculator here. And I did my domain right here. I said x has to be greater than or equal to 3 because I want you guys to look at this. This is what it looks like, right? This is what happens when I switch the x and the y values, right? And they end up being, you would be able to fold it over this y equals x line, and they would match up because every x is y, okay? If I took it off, if you wanted to see what the domain looked like, if I took this off, it would still look okay, but it would be the whole parabola because it's squared, right? And that whole thing does not match up if you fold it over.